Well, good morning, good afternoon, good evening, wherever you are. Welcome to another episode of Graph Hunter. So glad you're with us today. So glad to see some folks who have been with us for the first two exciting episodes of Graph Hunter. And today should be no less exciting because we're going to be seeing a live demonstration of Argos. That's right, we're going to actually really uncover the secrets of Argos, and it'll be great to see that. So, about us, first of all, I'm Corey Summers. I'm Chief Marketing Officer at ArangoDB. And over to Martin.
And I'm Martin Kawas, and I'm Product Manager in Cogniver. I cannot imagine it's already third episode.
I know it's wonderful, and of course you can watch if you haven't seen the first two episodes. The first is kind of the conceptual overview, but the second we have some rave reviews from that. It's somewhat in-depth. We'll have more in-depth coming up, but a look at the architecture and of the application and some of the design principles, and a really great discussion about graph RAG versus other types of RAG. And it's really such an interesting talk that we had. We'll review a little bit of that today before the demo. So what are we going to do today? We are going to first recap episode 2, and then Martin's going to show a real world scenario, kind of a story that will drive the demo. So it won't just be a generic demo, there'll be a scenario, and that'll be really exciting to see it in the context of that. Of course, we'll do that in-depth live demo, and this will be really a great look at how this whole idea of natural language and asking these questions in this way can be integrated into any application. So Argos already was a great application. Now they've added this piece to it. And of course, Arango is behind the scenes there. And then if you have Q&A, please do submit those questions as we go through the Q&A panel, and we will take them up. So Martin, over to you, a little bit about Cognaware real quick.
All right, so Cogniver is a company based in Prague, Czech Republic, but we have worldwide presence. And what we do is actually we are providing consultations and we are implementing data analytics solutions, especially for law enforcement, government agencies, intelligence agencies, etc., but also for the commercial sector. So investigation in banks, insurance companies, or security departments of any industry company. This is what we do. And we have a lot of experience over the 10 years we are on the market. We have over 100 projects, and that gave us kind of good expertise and knowledge about how those data analytics solutions should work. So what we've decided a couple of years back that we will build our own product that is called Argos, and is actually helping us to implement those data analytics. Yeah, if you want to hear more about Argos, I believe you just mentioned that the previous episodes we're covering this. We will show live demo today, but very briefly to explain what Argos is data analytics solution that is working with graph database underneath. So we have embedded ArangoDB and we have put application logic and user interface on top of that to really tailor it for investigators and data analysts that do not possess any high technical skills, and they want to go directly to solve their most important questions. So we made it for the analysis of timelines, relationships, multimedia, and put that together.
And just to reinforce the point, Martin, Argus in this context is around government and commercial analytics, but the application could also be used for fraud detection in financial institutions. There's really no limit to what you can do with this. Is that right?
I believe so. It has been designed this way that it's really customizable. The data model can be changed very quickly. And it allows you basically to understand suspicious behavior and suspicious relationships in any domain you wish. Fraud detection might be one of them, of course. But you can go wild with this software. You can investigate anything that is of your interest.
So real quick, I think folks know about ArangoDB, right? We've got the multi-model graph database, which gives you that flexibility all in one platform. We've got different use cases and solutions, this being one of them. Well, Argos, its own bespoke solution. We've got the progressively more advanced capabilities as part of our data science suite now, Graph Analytics, Graph ML, and Gen AI. A lot of exciting things in Graph ML that I've been working with lately. I know Michael as well here, and predictive analytics in the area of fraud or recommendations. Really some exciting stuff. So I encourage you to take a look at what we're doing there. And then we've got our basic visualizer. Of course, what we're going to see today is a far more advanced visualization concept. So, Martin, I know that your application itself is very user-friendly and flexible, but you're adding this, taking it to a next level, making it even more user-friendly with the asking of these natural language questions, correct?
Yeah, this is the most obvious, not in the simple questions like how two people are related to each other, but if you want to ask more complex questions, we have this visual editor, and I will show this live as well, where you can define your query. Basically, you're wrapping AQL with sort of Vysiwyg editor, like visual editor that builds your question. But we thought that large language models and natural language interface might be even more approachable way how to ask those questions, because you need to know how the data model is structured, what entities are connected with what. So why not to just bypass that and put the natural language interface? So I think it works quite well, and this is the way to go in the future. Not to spend more time on the user interface when you just want to type the question, or even if you want to say the question using voice interface.
And because you know the schema of what you're dealing with, your system is almost pre-trained already, so you can ask any question that you like, which is unique, right?
That's right. All data are interconnected, so it's about the graph traversal functionalities that helps you navigate through the very complex charts. And yeah, as you've mentioned, we know our data model, but that doesn't mean that our clients or our users need to know it. So we are trying to solve this for them.
It's not just structured graph data, but I know textual documents, PDFs, all kinds of things are also leveraged. Is that right?
That's right. There is this metric, I believe it's from Gartner for quite some time, that unstructured data are making like 80% of all the data volumes available. I believe that this is more true when the time goes. A lot of important information are in the structured world, stored in Arango directly, but a lot of information is embedded in textual documents, especially. And what we are trying to do is try to extract those textual information and put them into the graph so we can work with them, unified in the same way.
So give us an example of graph rag and how you're doing it. By the way, this is a bit of a religious war now. A lot of focus on graph rag being really the optimal way to do rag in applications of this nature because of the rich context you already have that's inherent in the graph itself. And so it's easy to do that traversal to get those rich results in a high performance way, right, Martin? I mean, when you compare, normal vector store rag to and other types of rag to graph rag, it's a richer result and more cost effective in some cases.
Yes. So, each of these has its benefits, but we are moving towards graph rag for multiple various reasons. One of them being that with GraphRag, when you're representing information as entities and links between them, and you make co-resolution, that means you're actually matching other objects in your graph, you're expanding your context of information quite significantly. And this is something that is hardly achieved in the traditional vector store RAG. So what we are trying to do, we are using large language models and specialized libraries to actually extract entities like person, organization name, location, event, topic, and so on from the textual content. And we are representing them and storing them in ArangoDB, just as regular entities. And we are doing traversals on top of that. We retrieve the results from Arango, and these results will be fed into the large language models to be represented as natural language answer for this. It has a lot of benefits. One of the benefits is, as I've mentioned, expanding the context. Second one is that the context window that large language models are capable to work with is very limited, especially right now in the open weights models. So we know that there are some commercially available models that can handle quite large context windows, but for highly secured infrastructure, as we are working with Argos and Incogniver in general, we need to have models deployed in secured infrastructure, and these models available right now have limited capabilities. So this GraphRag approach gives us a lot of options how to bypass and how to mitigate the problem with large context window, because the graph traversal will get us the most important information, the most relevant information, just using AQL.
And Martin, I know, I think we've talked about how Arango is unique in providing that full JSON document support, even nested JSON, which is very unique for a graph database on one platform, so not having to have a separate database. Is that JSON support, rich JSON support, important in this context?
It actually plays quite crucial role because you are always storing the reference texts. We are embedding or encoding this information into entities and links, but we still need to have those references. We need to trust the system. And this is, one of the problems of typical large language models is the hallucinations, it's making up things. So we need to make sure that what we answer is just, backed by the source. So this JSON store is really crucial for us to store the snippets of text from where we have those information. So this is just one great example how we can blend the technologies together and not to introduce new capabilities from different software.
And real quick on this, I know, again, we've talked so much about the vector store RAG, the graph RAG. We have examples where it's exponentially less expensive with graph RAG. I'm sure there's cases where it might be more expensive. What's your view on how these compare here?
To be honest, for us is much better because we have one technology. So the graph RAG shares the same concept if we are doing questions in natural language on top of the traditional ArangoDB collections. So it's just natural expansion. It's building on top of each other with one technology. We don't need to introduce new vector stores and calculate similarities and so on. What is great, ArangoDB with GraphRag gives us the way how to expand the context. And that means that it must have, by its essence, it must have better results because you're providing more relevant information. The problem with similarity search, if you ask the question in a bit different way than the actual documents are written, and the similarity search will fail, you will lose the contextual information in that. You will lose some important pieces of investigation. And this shouldn't happen with a graph because we are doing, the graph retrieval and traversal the same way we are doing with structured data.
So we have a question from the audience. Mm-hmm. We also, when doing this, we get to see the query that's being executed, right?
If the question is if we will see the queries on top of Arango. We will tackle the architecture in the next episode. And We will show exactly how we are doing this, because we are not creating AQL queries directly, but we are using our API, and we are building with LLM, we are building our API call, and then we have some business logic to translate this into AQL. So this gives us more flexibility in terms of security, auditing, etc., etc. But you can actually do the same thing as ArangoDB is providing in the LangChain agent that is available by the team. Maybe you can expand on that. But that's the logic that will create the AQL queries automatically. But we will expand the technical side in the next episode. In today's episode, I will show you how the API calls are done.
Yeah, it's interesting, just to quickly clarify, right? With our LangChain integration pack, which is kind of out of the box for us, we give people the ability to connect the LLM, generate the AQL, access the graph. There's some training involved there. What you're talking about is kind of that in the next level. You give more control, more security, more specificity around it, right, Martin? It's the same concept, but just different implementation, right?
Exactly. It's exactly as you've mentioned. We need to have more controlled environment, because the data we are dealing with are of the sensitive nature, right? These are highly sensitive data with some validity, with some approval workflows on top of that, and we need to audit, every access to this information. So in that sense, we needed to have extra layer, because once you expose AQL directly, you can ask anything, but we need to restrict that a bit, because not all departments of certain organizations are able to visualize the same data.
Yeah, I do encourage those who are interested in doing a chatbot style on top of just your graph, any type of custom application you want to do that against your graph database. Our LangChain integration pack will make that extremely simple, takes a lot of the effort out, dynamically generates the AQL, but again, not to the level that we're going to see today. All right, let's keep moving, get to our demo. This is the background story. I love this. And I see you here. Am I led to believe you've had some legal problems, Martin? What's going on here?
I tend not to use different faces with multimedia analytics and face recognition. So I'm protecting myself from legal issues. So the story, one caveat or one disclaimer at the beginning. Obviously, all of those information I will be sharing and showing, these are dummy data created just for the purpose of demonstrating the capabilities of our software. It doesn't have anything to do with the real life scenario or real life data. However, the concepts are, I believe, the same. So our story will be tailored about Hans Schneider, a typical 45-year-old resident of Berlin in Germany. And we received some intelligence report that he has been suspected in the involvement in criminal activities like drug trafficking, vehicle theft, and potential ties to extremist organizations. And it is believed that Schneider may be part of some larger criminal network that goes beyond the Germany. And what is our job as data analysts and operational analysts in police department is to use Argos software with large language model capabilities to unravel the network and understand the behavior and links of Hans to other entities. So most probably we are interested in cases that are relevant to Hans Schneider, like cold cases or active cases, and associates or the people involved in all the activities that Hans is doing. So for this, we will use ArangoDB with Argos and large language models.
And just to extend this to the fraud example, Martin, it's almost like you could have a customer or some user suspected it might be a fraudulent transaction. You then think maybe there's some role of that person in a larger fraud ring. And then to unravel that fraud ring, you would use this approach. So again, it's not just, or it could also be different commercial entities that may have trademark rights violation, anything you can think of right here.
Yeah, actually, in the previous session, I believe I've mentioned the conflict of interest use case for the commercial companies, where you investigate when you're a company issuing tenders, you want to be sure that people evaluating those tenders are not somehow related to the companies that are participating in those. So this is the typical, the typical scenario, still the same concept. We have some suspects and we want to either confirm or deny our hypotheses.
Now we're getting into the Jason Bourne area. We're getting into what you're looking at, these reports and alerts, right?
So actually, these 3 steps that I introduced in the scenario are the things we've discussed so far in the 2 episodes. First one is I have some police report written in German language, and I will use large language models to understand the police report, to extract some entities, and to get some summary of that. Next step would be to retrieve all the linked information of our suspect. So we will collect all the data. And for this, I'm mimicking multiple data sources, which are typical for these types of investigation. So we have CCTV video feeds or camera feeds. We have criminal investigation database where you have the past investigation cases, some criminal history or criminal records. Then we have call data records database. This usually comes from mobile operators, gives you events about which person is you or which subscriber is using which SIM card with which device from which cell tower at which time. So this gives us approximate location of the person and the communication counterparty. So we know exactly, who are the people that have received phone calls from that suspect. Then we can have vehicle registry. So we may have information about the cars, like license plate numbers. And this can correlate with CCTV video feeds because most of the organization, basically all of them, are having automatic number plate recognition capability that extracts car plates from video feeds and gives you, again, location of a specific car at a specific time. And you have in-vehicle registry more information about owners. Then we may have bank statements. Again, if you have subpoena, you need to request information from banks. They have some obligation to share the bank statements with you. We can parse those and store that information in ArangoDB in a structured way where we can do some analysis on top of that. And the last one may be some textual report, which is kind of frequent. So we need to extract some entities and we need to understand the texts that are there. So these are the retrieve linked information stage. And we will be retrieving this using textual inputs. So far, we have capabilities in our user interface, how to retrieve those information in a specific screens with specific visual controls. But we have introduced a new level of interaction with the chatbot or virtual assistant, if you wish. And then the third step, the final step, would be to produce some investigation visualization and write some report with large language model. So once we have the structured data of our investigation, we can feed this into large language models to be inspired to write some report that we need. So this is like the core idea what I will demonstrate.
And real quick, because I want to get to the demo right away. What is those textual inputs you talked about here in step 2? Some examples here.
Yeah, so it's about retrieving all those information that are stored in ArangoDB. We will be focusing on communications, so we need to identify who are people that the suspect is calling to. We will track movement, so we will see what are the locations the suspect is visiting, if those locations are somehow linked to previous cases. We will uncover financial transactions, so we need to understand if there are some potential chained transactions between, for example, 2 suspects. We can use multimedia files to understand if 2 people know each other, and we might identify other cases using, again, graph traversal, that the suspect might not be directly linked to the case, but there might be indirect connection that helps us to expand the context of our investigation.
Yeah, I know that Michael on the call has shown some cool demos with fraud, how we use social security numbers, phone records, and all these other things to identify the fraud ring. So same kind of concept. All right, let's get to the demo.
Okay, so folks, what we are seeing right now is the user interface of our investigation tool, Argos. Just disclaimer, this is version 2.6. We are right now working on redesigned version 3.0, which should be available somewhere in autumn. So it will be even better. But for now, let me show you this kind of version here. What we are seeing here is catalog. This is like the list of entities and types of links that are available in our solution. So as you can see, we have entities like person, organization, weapon, SIM card, bank account, etc. Now we have a lot of ways how to query data, how to visualize data in our solution, and I've been showing screenshots in the first episode. What we introduced right now is this sort of Argos AI assistant on top of that, that is helping you manipulate with the content directly from this panel. So what I will be showing you right now is we will try to upload the police report written in German language. So we have three main tasks that we are doing with the Argos AI assistant. And by the way, for now, we have introduced a bit different context of working with chatbot. You're used to have the prompts like question answer in chat style. What we introduce right now is more like question answer way of visualization, because it better fits the, let's say, data analytics and investigation part. So let me show you that. So the first step is to analyze the document. We can upload any kind of content in here, but I created this investigation report in German language. And what it's doing, it's parsing those content on the server. And in here, we have the plain text representation of the document. So we can preview the actual document, the original content. I speak German very little, so it would be very hard for me to understand the context, right, or the information. So would we train the system, or would we instructed the large language model to do, is to represent the document in English language. So it provides translations to the currently selected language of the user interface, and it detects the language of the original document. So in here we have the automatic translation. Suddenly it becomes much clearer for me, so I know what is written there. But what we've instructed the large language models as well is to provide us some summary of key entities. So we know that it gives us idea about what entities the document is mentioning. With some simplified summary, because most of the time I'm browsing through tens of documents or hundreds of documents. It takes quite a lot of time to go through. So the simplified summary is really vital for the investigators to go through. But this is not the core part. The core part is that we also instructed the system to extract the entities and links and store them in AringoDB graph. So this is sort of, let me switch to the full screen. So these are the entities extracted from the document, and it was actually matching them with co-reference or entity resolution rules. Again, using those large language model capabilities. So you can see there are these entities mentioned in the text written, and for example, Hans Schneider, this is the key entity in our investigation story. He's been matched with the object already stored in AringoDB. So what we can do, we can actually click the detail, and in here we have like 360-degree view of that person. Here, in the traditional way of working, we can see the metadata that are correlated from multiple different sources. We have biometric management available, so we have multiple photos. We can see which multimedia are displayed. We have maps view, activities view, from timeline perspective. We see in which cases this person is part of. We have the connection view, so I can actually go through the visualization of the network chart interactively. But what we want to do is I want to use the large language models to ask contextual question based on that person. Now I can we have this interface where we select the target ID about which we want to ask the questions. You can type whatever person is in your database. But what I want to introduce is I want to set the active profile. So usually when I'm exploring this person, I want to be notified about Hans. So I have a couple of questions that I want to ask about this person. I have written them in here just so I'm sure that I have put there correctly. So I want to show contact that this Hans Schneider has communicated with via his phone in the past year. So what I will do, I will ask the question. So everything is running on our infrastructure. We have some models deployed, which should be quite fast for these types of questions. And we will receive three types of information. We will receive, first of all, textual response for that. So it asks the question for our backend API. It retrieved data from Argo AQL. It returned the result, and we are, let's say, narrating those structured results with textual response. Then we have this graph query. So this is actually our pseudo syntax, how we are representing those queries. So this gives me idea that I need to search for linear path, and I'm looking at all SIM cards that are related to Hans Schneider, and I'm looking at the CDR events that are linked to that SIM cards. So everything is written in this pseudo syntax, and this gives you idea how you retrieved those results. The third part, what we have is actually link to the user interface that is capable to visualize the information that we retrieved. Because our philosophy is that we don't want to introduce most of the widgets that would be too complicated to display information in very small and limited space. Rather, I want to click this button and I want to visualize all those results that have been somehow summarized here in the screen that has been already created for us, right? So what large language model did just now, it created a query into our system that fits the current capabilities. It took the result, it put some analytics on top of that. So for example, it gives you information about which kind of sensitive SMS were present in those results. You can actually see high volumes of activities and so on. So this gives you quite nice extra layer of explanation what is happening. Of course, this can be more tailored for your specific needs in the future or for your typical workflows. But I think this is quite very quick way how to do these types of questions. Of course, you can narrow it down even further. So for example, this person is part of the investigation, and I can see only on the visualize only communications between the two of them. So Hans Schneider and this guy. I can see there are 25 interactions, and I see the statistical information about those integrations. So we know that 8 times or 3 times they were making interaction at Sunday morning, which is untypical, of the other interactions. So that kind of analytics, I think it's very, very nice to see. So again, large language model, really cool way how to just type the question and get the answers. So this is about the communication. Another type of question might be related to locations where Schneider visited, a couple of times in the past. And here I can again see the results visualization, and I can see 3 three locations in here defined in specific dates. And let me visualize them on a map. So it's center of Berlin, and here are the locations. Now I might be also interested in which people were there. So again, I can focus on the capabilities that are already there in the system, and I can quickly, just 2 clicks or 3 clicks, I can visualize Lisa Miller and Mark Becker being there at certain times, which are overlapping with Hans Schneider, and we know that these locations are related to drug dealing. So it gives us idea about who is there and why, and we can visualize this on a map.
Quick question, 2 questions. One is for cybersecurity use case. This could be cool, right? To see where people are attacking from, right?
Sure.
Yeah. And then, ArangoDB has the built-in GeoQuery, geospatial capability. Are you using that here or using something else here?
Absolutely everything is built on top of ArangoDB. So all the queryings. By the way, we have quite nice map queries. So if you want to visualize information in a certain area, you can use the polygon search. The map, I'm not sure where are those data, but all of those questions, that can be answered. This is on top of ArangoDB with embedded geospatial capabilities. This is why it's really easy to implement large language models on top of that, because we are leveraging one technology, and we wrapped all those functionalities with one API already. So it's just learning function calls of large language models to use differently. But yeah, cybersecurity might be one of the visualization options for the use cases to have. All right, so these are locations. I've been mentioning financial transactions. So let's ask the question, we want to identify large financial transactions made by Schneider in past days. So in here, we have, again, some graph query, and we have the results visualization, again, some textual output of the investigation. So transaction timeline, largest transactions, suspicious activity indicators, everything that is, utilizing large language models with the existing data with limited or with no non-existing hallucinations, because it gives us only the core information in here. So this gives us idea about what are the number or account numbers with the frequencies and some statistical information. Another type of question that can be asked quite nicely is, we want to retrieve multimedia files where Schneider is seen with known criminals. Okay, so with known criminals, it actually means that people are on watch lists that is of a type criminals. This is somehow very, very cool thing. So let us see the graph query for that. So for this, we actually visualized or trained the model to be represented in this screen, where we have Hans Schneider on one side and drug criminals watch list on other side, and we can use watchlisted people on the same multimedia files pattern. So Gunther Fischer has been seen with Hans Schneider on this multimedia file, and he's part of drug criminals watch list, so this is a bad guy, and they've been spotted together. Again, it depends on the type of use case you're dealing with. Most of the time, this comes from CCTV cameras, but it might come from multimedia, from social media. So just to give you idea how this technology is working, I can visualize Hans, I can visualize this Gunther in here, and it links us, those two people together. Again, we are storing this in ArangoDB, because automatically using facial recognition and API and AI models, we're storing this in structured world, and it allows us to traverse it and have this in one place.
This is definitely Jason Bourne level. Come on, Martin. This is so cool.
Right. So these are like retrieving those questions that might be interesting for you, and it's really a shortcut for the application. You don't need to click it, manually over and over. Now let me show you one thing. We have this functionality called patterns in our application. Basically, what we have, you can create in Visual Editor, very complex questions like this chain circle for white horses in the financial transactions, and etc. You just click the entity you want to create, and you just create a link between that. You put restrictions or conditions for that, and this will be transformed into AQL effectively with some controlled level. Okay, so very complex question into the database. But the problem is that for some people it's okay. For some people, this is too much clicking. So what we thought is, let's use large language models to shape questions like that. Bypass this visual interface, bypass the AQL syntax, but ask the question directly. So let me show you one thing. We have this boards functionality, which is effectively blank canvas that allows you to add information on the screen. So I can visualize Hans Schneider, and I can add different people, Gunther Fischer, and each object may be, again, using this interface, expanded and worked like that. Okay, but let me show you alternative way of working with this. So let's go to the asking of generic questions. Let's see if this will work. Hopefully, yeah. So I just asked, add me to the board all locations related to Hans Schneider and other people or vehicles in the overlapping time. So what it queried, what it did in the traversal, we took the Hans Schneider and we retrieved those 3 locations I've been showing you in the previous screen, and it extracted for each of those locations those different people. So Lisa Miller and Mark Becker, I've been showing you this, and these are vehicles on that specific location. All right, we can let's say go further. So we stick with one visualization. We can just expand things. So let me copy this question. Expand me information about investigation cases. Right. So yeah, it took some time, but if I redraw this, so it kept all the information there. It just put there those investigation cases. Again, those information are already present in the system, so we have them linked. We can continue our investigation, but it gives us sort of next context. But suddenly we know that Mark Becker, who was spotted at that location, which is drug spots, so most probably place used by drug dealers to ship the drug packages here, and he's been part of car theft investigation for one of the vehicles spotted at location which is same for Hans Schneider. And suddenly we are connecting the dots. This is the typical graph traversal and linking things together. All right. So it starts shaping, those relationships. Let me add additional information. Let me add links between Hans Schneider, and you remember the guy Aras Özdemir. This was from the guy from the report. So we'll see if the coreference resolution will match those guys together, and it will provide some financial transaction chains. Bam. So in here we have this guy, right? And it found his bank account and Hans' bank account. But it is not direct transaction. This is just to show you that the graph traversal goes, in the chain transactions as well. So there's actually one counterparty in the middle that connecting them. Again, it depends on the access for the information. So you need to have access to those information in order to find them. But most of the time, there are ways how to retrieve such from banks or mobile operators or any other agencies. So please take this as just inspiration of all the capabilities that are there, right? So again, we found very nice connection between this guy, which is non-trivial and non-direct. It would be difficult to find it in a typical way. And now let's conclude this. So we have some information in my investigation chart. I can save this investigation chart. Okay, I can name it. I can share this with my colleagues. I can keep it private. I can create multiple of these, describing each stage of the criminal activity. But what I want to do, I want to leverage the large language model to create me some draft of the final report. So create me a draft of the final report based on my findings in the investigation board. So final police investigation report. We have case overview, and it gives us, again, based on some templates, based on prompt instructions, and you familiar with large language models, this is configurable, okay? You can instruct the system in various different ways how to produce the output based on your ideal policies and let's say templates. So what it did, it just took all the JSON data in structure format that is in the investigation, and it rephrased them in the way that the LLM instructions are created. And what we can, we have visual editor, so you can change the text, you can create the final PDF out of this. You can continue the investigation.
Imagine the productivity boost, but also, I mean, this is incredible. Can you, in the final report, can you include the visual, or is that separate?
Yeah, sure. Why not? We are working even more advanced way of creating interactive reports that can be shared outside of the organization. By the way, this is one of the most asked feature, to create like the investigation case output report, even for people that do not have access to those systems. So yeah, why not? We can combine these things together.
So this could be like if you think again about different use cases, it could be a fraud report, it could be a cyber attack report, it could be a patient. You can see what tests a patient has had that other patients have had. What is their risk of different things? It could all be in here as well, right? I mean,
you can actually think even about more use cases focused on creating value. Like if you have CRM system visualized in our solution, you can ask questions like, what are the most prominent customers, or what are the opportunities that are really the most important ones, and I shall focus on that. You can go into many different directions, not just police investigation. This is for demos. I believe this is the most like natural and easy to explain, but we can really go in different direction, not just a forensic investigation of what happened, but what might happen, like what if scenarios, like what is the likelihood of creating a business deal with these sort of clients based on the past data. All the data are in graph, and you've mentioned the graph ML, right?
Yeah.
I believe this is great extension of
yeah. Well, that's the next thing on top of this, which is predicting the crime before it happens, right? And that's possible with our GraphML package in our data science suite. It would then need to be put into here, right? I mean, but this is incredible. I've never seen such a rich interface. What I loved about this was as you added to the board, and then you kept asking additional questions, and it put the information into the board that you already had. That is really nice.
Yeah, the thing is, you can do this manually, right? You can expand on that manually. So for example, the source of the information, this is the investigation report, so on. But this is much quicker if you just ask, and it follows your thinking about the investigation. And by the way, what we can do, because this is wrapped with the API, so we can create like investigation history. So we have prompt, result, prompt, result, prompt, result. Again, it gives you quite nice idea about how to utilize those.
I've never seen anything like this. And I love the fact that you could add different use cases in here. It's not just the crime use case. Sky's the limit. But I really got to applaud you on the UI. You know, aside from the natural language, which is incredible, the UI of your application, it's so rich. And there's so, like you just showed us another piece, and then you could probably geolocate these things as well.
Everything is interconnected in a way. So it blends like the natural investigation flow and intelligence cycle. So we follow, it has built-in case management. So you start with case and you limit your investigation with the context of the case itself and so on. Yeah.
Outstanding.
Cool.
All
So
right.
maybe I will wrap this up because what we've seen so far is basically what I want to show you in the story. That I will retrieve it. Yeah, in this form. So our main job was effectively to find a connection and confirm a connection between Hans and other people mentioned in the report. One of them being this guy, Argos, and we know that this guy is somehow linked via financial transaction to Hans. So he's feeding the money there. And we know that he's been seeing or spotted with people that were somehow included in car theft in the previous cases. And at the same time, those locations were suggesting that these people or these locations are for drug dealings, so effectively, something like these.
And again, with hallucination, if you asked if I was related somehow, me, Corey, to this guy Hans, it wouldn't create that out of thin air, right?
Corey is not there. Corey is not
Right?
not in our graph database.
Yeah. You know what's weird about sometimes chat is you ask a question and it just it almost takes your question and makes it real, right? It's like,
But I think in next episode we will tackle the issues how this actually is done or how we are doing this. We don't want to overexpose things, to be honest. But we want you to get interested, and if you want to see more demo, because this is we prefer to have like one-to-one demos with our clients. So if you want to see something specific, please reach to us, and we're happy to discuss the details with you.
I think the huge opportunity for you guys and what we're doing at Arango is we have these GraphML demos for different use cases. So fraud, recommendation, patient 360, all these different ones. Seeing the fraud or the cyber in your interface, I think would open people's eyes to what's possible for Argus. Because why should Argus, right? It should be the sky's the limit, universal, right? Because what a beautiful application you've created. I have to applaud you and Cognaware. And I know Marquetta does a wonderful job getting the word out for you guys. So incredible work today. I have a Q&A. I don't see any questions as of now. What I love, though, is everyone who logged in stayed with us the whole time. Martin, that is a applause for you, showing, I mean, all those attendees to be able to stay the whole time. They were riveted, I think, by that application. So congratulations to you on that. Our next episode, which will be the in-depth Argus architecture, we're going to get into the technical exploration. We got a lot of thumbs up and high fives and love it. So thank you so much for that. We're going to go really deep into that whole API thing. How does that work? I want to talk about how that compares to our line chain. So maybe we'll have Michael on or Anthony on to go into our piece of that and compare and contrast. What do you think of that, Martin? That would be cool, right?
Sure, absolutely.
Yeah, we're going to show you in that one the Argus way that they do it. It's all AQL eventually. It's how you get to that AQL is what I'm hearing. And we'll show you the line chain pack that we have that lets you today, anybody go and connect these things and use a chatbot against your graph, which I think is really cool. And then, yeah, those second 2 points are what I just talked about. So I love how Graph Hunter is progressively diving into the detail, coming up for the high level, diving back down again. And I've really enjoyed this with you, Martin and Marketa. I suggest everyone take a look at Argos as a possibility for your use case, which it's not limited to just criminal things. So again, I'm blown away by the application. You should be really proud of that. Any final words, Martin?
Yeah, thank you so much, Corey, for all the help and for the good narration. And I just want to stress that, guys, if you're interested in Argos or in general in Cognibware, what it's doing, please let us know. Let's have a separate chat. We can walk you through the technology separately. We can give you more insights about what we are doing. Maybe that would be inspiring for you as well.
Okay, well, with that, everybody, we will wrap this session of Graph Hunter up, and we will see you on July 23rd for the next exciting episode of Graph Hunter Deep Dives. Take care, everybody.
Thank you so much, guys. Thank you, Corey. Have a nice day.